In a division problem, the product of quotient and remainder is 24, while their sum is 10. And so quotient into remainder is 24. Quotient plus remainder is 10. And so very simple question. Quotient and remainder are nice integers. They have to be positive. So 6 into 4 is 24. 6 plus 4 is 10. We don't need to solve a quadratic equation. We know this. And so either quotient is 6 and remainder is 4, or the other way around. And so we told the divisor is 5. We are dividing by 5. Obviously, straight away, if we are dividing by 5, the remainder cannot be 6. The remainder has to be 4. Right? We ask for the dividend. What is the dividend? So the remainder is 4. The quotient is 6. It cannot be 4 here and 6 here. We're dividing by 5. We can get 4 as a remainder. We cannot get 6 as a remainder. We want to find what number that when divided by 5 gives a quotient of 6, the remainder of 4. This number is 5 into 6 plus 4. 5 sits in this number 6 times and leaves a remainder of 4. 30 plus 4, 34. Very simple, very routine question. Fine. Chances are the questions in your exam are far tougher than this. This did appear in the exam. It's one of the simpler questions. The shortest distance from the point minus 4, 3 to the circle x square plus y square equal to 1. That seems like a seemingly tough question, but it's not that difficult. And so let's draw this circle. X square plus y square equal to 1. It's a nice circle. With the origin as center, radius is 1. The point here will be 1, 0, minus 1, 0, 0, 1, 0, minus 1, etc., etc., etc. We want to find the distance from the point minus 4, 3. This 1, minus 1, minus 2, minus 3, minus 4, 3. 1, 2, 3. So somewhere here. Right? I'm roughly marking the point. The shortest distance from the point minus 4, 3 to the circle x square plus y square. You want to draw a shortest distance to this. You can draw some line cutting through this secant. You can draw a line just touching that. That will be a tangent. But tangent is perpendicular to the radius. Tangent as a line will be the radius distance from the at a perpendicular distance of the radius from the center of the circle. Right? Will the tangent be the shortest distance to the circle? Is that point the shortest distance? So maybe the tangent is going to be somewhere here. If we draw a line like this, is this point the closest to this tangent? Probably something like this. I don't think so. You can have a point here that is even closer. When will this be closest? What is the closest point on the circle to this? Not anything here, not anything here. All that will cut the circle beforehand. Anything you draw a secant, you won't do to the other part. Tangent, there's only one point of contact, but I can already sense the point here will be closer. What is the point? Very simple. Join this to the center. This point is going to be the closest to the circle. And to any other point be farther than that. Think about it. The closest point on the circle to this, join to the center. Wherever it hits the circle, that will be the closest point. And so if you draw a point somewhere here, that distance length will be longer than this length. And so this length will be longer than this length. So join to the center, find this distance. So this is 3 units, this is 4, or this straight line is 5, radius is 1, or the shortest distance is 4. Actually a very simple question, beautiful question, because what we are trying to figure out is from a point outside to a circle, the shortest distance, where will it be on the circle? Join the center, join to the center, and then wherever that straight line hits the circle, that will be the shortest point. It's a very interesting exercise to try to prove that. Obviously, it's a very interesting exercise. I'm not going to do it. Try it, give it a shot. When the shortest distance is this line from the point to the center of the circle, wherever that hits the circle, this point is going to be the closest to this point. So how do we actually compute it? The numbers are very good. Minus 4 and 3, distance of 4, distance of 3. This is the hypotenuse. So we call this as P, call this point as Q, center as O, PO is 5, part of a right angle triangle, 3, 4, 5. We call this point as R. PR is 4, because PO minus OR. OR is 1, PO minus OR is 5 minus 1, which is 4. Right? Lovely. Now I'm going to think about why that line should be the shortest, or I'm not going to think about it. I'm not going to give you the answer. I'm going to give you a starting point. Draw a circle. From a point outside, draw a line to the center of the circle. Right? Now draw another line here. Line here. Lovely. I'm going to think about this triangle A, B, C, of which CA is the radius, CD is the radius. We want to prove BD is less than BA. You're saying BD is the shortest. On any other arbitrary point, you're saying BA is longer than BD. What are we going to use? We are going to use the idea that sum of two sides of a triangle is always greater than the third one. Use that and prove BA is greater than BD, or BD is the shortest. It seems intuitive, it seems easy, it seems clear, but this is how we would go about proving that. Again, I'm not going to give you the whole proof, figure that out. The minimum value of f of x, mod of x minus 3 minus x plus modulus of x plus 2 plus modulus of 5 minus x is equal to. Beautiful question, and beautiful question. To start with, we need to understand one funda. If you have 2 points on the number line, P and Q, distance between these 2 points is nothing but Q minus P, larger number minus smaller number. 4 and 5, 5 minus 4. Minus 4 and 2, 2 minus 4. 3 and 7, 7 minus 3. That will be the distance between these 2 points. If you're given just 2 points on the number line, how do we know which is greater? Some P and Q on the number line, I don't know which is greater, which is lesser. The distance between them is modulus of Q minus P. Modulus of P minus Q. Other takeaway here, modulus of P minus Q is modulus of Q minus P. They're same. Talking about modulus. Whether I'm doing 3 minus 5 or 5 minus 3, modulus of that is going to be 2. Beautiful, very simple, very wonderful idea. Right? So therefore, I'm going to rewrite this point. I'm going to say this is modulus of x minus 3 plus modulus of x minus minus 2 plus modulus of x minus 5. Right? You don't even need to rewrite this, but I'm rewriting that. Why? Because I'm going to think about the points 3, minus 2 and 5. Those are the 3 points that are interesting to me. So now I'm going to mark those 3 points in the number line. Let's draw the number line. We're going to talk about, let's put a 0 here. We want minus 2. We're interested in 3. 1, 2, 3. We're interested in 5. Right? Now, if our point x were anywhere on the number line, so it could be this side, it could be that side, it could be somewhere in between. Anywhere on the number line, then let's say we have a point x here. Then this distance is modulus of 2 plus x. This distance is modulus of 3 minus x, or modulus of x minus 3. This distance is modulus of 5 minus x. Beautiful, so far so good. So this whole question is saying find the minimum value of this distance plus this distance plus this distance. Lovely. So now think about it. Our point can be less than minus 2. It can be more than 5. It can be between minus 2 and 5. Right? If it is less than minus 2, I'm going to measure this distance all the way till 3, all the way till 5. If it were at minus 2, I'm measuring 3, 5. If it were at 5, I'm measuring 5 to 3, 5 to minus 2. Right? So the funda here is very clear. You're measuring from x, distance to minus 2, distance to 2, distance to 5, and adding all of them up. Straight away, we can sense that having a point in between minus 2 and 5 is easier. You're going to simplify your distances. Otherwise, think about it. I calculate the distance from x to minus 2 and then x to 5. This entire 7 is extra. And then x to 3. This x to minus 2, I can imagine x being at minus 2 and this distance being removed from all 3 lines. From all 3 lines, this distance will be removed. So minus 2 scores better than any number less than minus 2. Exact same reasoning. 5 will score better than any number greater than 5. Or quite simply, the best case scenario is if our number sits between minus 2 and 5. So now let's chase that. Let's draw the diagram again. Oops. I'm going to talk about minus 2, 3 and 5. I know x has to be in between minus 2 and 5. So I'm going to imagine this somewhere here. So this is the distance between x and minus 2. This is the distance between x and 5. And this is the distance between x and 3. So we add this, this and this. Okay? Now think about this. If our x were somewhere here, and let's call it x1, call this x2. Minus 2 to x2, x2 to 5 and x2 to 3. We'll add these three. What I want to make sure that you get is the number, if it is in between distance to minus 2, distance to 5, those two always add up to 7. This and this adds up to 7, this and this adds up to 7. Wherever you keep x, here, here, here. So that number is 7. Now the additional part is only this distance, x to 3, either x1 to 3 or x2 to 3. When will that be minimum? Quite easy. Put x as 3. X lies between minus 2 and 5. The best case scenario is when x is 3. When x is 3, this goes to 0. This is 5. This is 2. Adding up to 7. Or the minimum value is 7. It will always be, the minimum value will always be the distance between the largest of the numbers, the smallest of the numbers. The middle number can be anywhere. The minimum value will remain the same. When the minimum value is achieved, when x is that middle number. Between minus 2 and 5, wherever x is, these two will add up to 7. And on top of that, if you want the overall total to be minimum, we look at taking this as low as possible. Put x equal to 3, best case scenario, sum is 7. Ashok purchased pens and pencils in the ratio 2:3 during his first visit and paid rupees 86 to the shopkeeper. During his second visit, he purchased pens and pencils in the ratio 4:1 and paid rupees 112. A ratio is given. 2:3 pens and pencils. He pays rupees 86. Next time it is 4:1 ratio, and these pens rupees 112. Lovely. The cost of a pen as well as a pencil in rupees is a positive integer. Lovely. We're dealing with integers. If Ashok purchased 4 pens during his second visit, then the amount he paid in rupees for the pen during the second visit is rupees for the pens during the second visit is. He purchases 4 pens during his second visit. So the ratio is not just 4:1, it is 4 pens and 1 pencil. Now this is wonderful. I don't want to deal with this ratio here. In the second visit, he buys 4 pens and a pencil for 112. Right? For the first time, the ratio is 2:3. So he could have bought 2x plus 3y for 86, or 4x plus 6y for 86, or 6x plus 9y for 86, and so on. X is cost of a pen, y is cost of a pencil. Life is simple, wonderful, all good. Right? Now, we don't know what to solve. It's 2x plus 3y, it could be 4x plus 6y, it could be 6x plus 9y, etc. etc. It could be 20x plus 30y, 20 pens and 30 pencil. Now we come to the beautiful other constraint, which is the price is not just an integer, it's a nice positive integer. 4x plus 1 pencil costs 112. 2 pens and 3 pencils costing 86, I can imagine. I'm already struggling with this. Why? Think about it. This is 4 pens and 6 pencils. 4 pens and 1 pencil cost 112. 4 pens and 6 pencils has to cost more. Pencil cost positive integer. It cannot cost less. Therefore, I can ignore all of this. My two equations are 4x plus y is 12, 2x plus 3y is 86. Multiply this by 2, 4x plus 6y is 172. Subtract 1 from the other. 5 times y is 172 minus 112, 60, or y is 12. Cost of pencil is 12. On his second trip, he makes 112 rupees he spends. of which 12 are for pencils, or cost of the pens, amount he paid in rupees for the pen during the second visit is 100. Beautiful question, because we get the ratio to start with, and then we say the second one is not just a ratio, it's actually 4 pens and 1 pencil. So 4 pens plus 1 pencil costs 112. We have that in the bag. It could be 2 pens and 3 pencils, or 4 pens and 6 pencils, or 6 pens and 9 pencils. Only it cannot be any of this, because if 4 pens and a pencil cost 112, 4 pens and 6 pencils cannot cost 86. We're not accounting for something being negative. That's clearly mentioned. It's not just a mathematical thing, it's a contextual thing. Cost of pencil is not negative, and more clearly it has been mentioned. It's a positive integer. So all of these we don't need to worry, just simultaneous equation, get it. In a 4-digit number, the product of the thousandth digit and the unit digit is 0. Lovely. Thousandth digit and unit digit is 0. So one of the digits is 0. It's a 4-digit number. The thousandth digit cannot be 0. Unit digit is 0. Dash, 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 0. Straight away, we got that. And while their difference is 7, oh brilliant. Thousandth place, unit place, difference is 7. This should be 7. We're dealing with a number that is 7 dash dash 0. Product of the middle digits is 18. These two multiplied to give us 18, or could be 3 into 6, 6 into 3, 2 into 9, 9 into 2. It cannot be 18 into 1 because we're dealing with digits. Right? The thousandth digit is as much more than the unit digit as the hundredth digit is more than the tens. Thousandth digit is more than the unit digit by 7. So the hundredth digit should be more than the 10th digit by 7, 7920. So 7920 is the number we are looking for. Quite a simple question. You should be knocking these off. Out of 80 students who appeared for the school exams in math, physics and chemistry, 50 passed math, 30 passed physics and 40 passed chemistry. It's like a classic set theory question. Math is 50, physics is 30, chemistry is 40. At most 20 students passed physics and chemistry. At most 20 students passed chemistry and math. At most 20 students passed math and physics. The intersection is a maximum of 20. Right? The maximum number of students who could have passed all 3 exams is, so this were x. We want to find maximum value of x. Okay. We have a wonderful formula. A union B union C is A plus B plus C minus A intersection B minus B intersection C minus C intersection A plus A intersection B intersection C. So I want to think about that formula. Out of 80 students who appeared for school exams, assume the total is 80. M union physics union chemistry is 80. There could be people outside also. The total could be less than 80 technically, but we're looking to find the maximum. I think 80 will work. Right? So technically, people who wrote none of the exams, that is a factor for us to keep in mind. I'm going to ignore that and say let us plug it at 80, because if the numbers are here, the total were not 80 but 78 or 75, it's quite clear that this number could go down. We want to find the maximum possible x. So I'm going to assume A union B union C is the maximum possible, which is 80. Right? So now I'm going to go to the math of it. M union physics union chemistry is M plus P plus C minus M intersection P minus P intersection C minus M intersection C plus M intersection P intersection C. So this is 80 is 30 plus 50 plus 30 plus 40. Minus M intersection P minus P intersection C minus M intersection C plus X. We want to have X as high as possible. And so 50 plus 30, 80 plus 40 is 120. This side is 80. Bring this whole thing this side. M intersection P plus P intersection C plus M intersection C is equal to 40 plus x. And so we want x to be as high as possible. That's our objective. Fine. We manipulated this and taken all the numbers away. M intersection P, M intersection C, P intersection C, all three come this side. We have it as 40 plus x. We want x as high as possible. These three should be as high as possible. We are at most 20. Best case scenario, put this as 20, 20, 20. This is 40 plus x. X maximum is 20. So the maximum possible value x is 20. Now remember that x is the intersection of M intersection P intersection C. That cannot be higher than either this or this or this. And so 20 is the maximum it can take anyway. It looks like 20 could work. I don't want to leave it at that. I want to plug in 20 and see if the diagram works clearly. 20 here. I mean, this is 0, 0, 0. Math total is 50, so it will be 30 people here. Physics total is 30, there should be 10 people here. Chemistry total is 40, there should be 20 here. 30 plus 10, 40, 60, 80. Total is 80, 0 outside. Everything works. The maximum is 20. Lovely question. Just manipulate some based on that one rule in one formula and set theory. Move numbers a little bit. Think about the maximum possible. You're good to go. Two friends run a 3-kilometer race along a circular course of length 300 meters. Their speeds are in the ratio 3:2. The number of times the winner passes the other. And so, lovely, 3-kilometer track. Fine. Their speeds are in the ratio 3:2. Let's say, forget even 3 kilometer. Let's say the lap length is L. Fine. Any time the first guy travels 3x, the second guy will travel 2x. Their speeds are in the ratio 3:2. They start, they keep going. The first guy covers 3x, the second guy will cover 2x. Right? Now, the number of times the winner passes the other. So, they start somewhere here. The quicker guy goes faster. The slower guy is slower. From the starting point, the quicker guy keeps on getting an advantage. He's going faster and faster and faster. He'll go so much faster that at some point of time, he'll catch up with the slower guy and then overtake him. Imagine in an F1 race where the guy gets lapped out. He'll go so much quicker that he'll come back all the way over and then overtake the slower guy. How much should he gain to overtake the second guy? He has to gain an entire lap. The quicker guy has to gain an entire lap for him to overtake. Whenever he travels 3x, this guy travels 2x. The difference between them should be an entire lap. Only then this will happen. 3x minus 2x should be one whole lap. When will that happen? 3x minus 2x is x, or the quicker guy completes 3 laps, slower guy completes 2 laps. That is when the quicker guy will overtake the slower guy. So when will the next time happen? The next time will happen when the quicker guy does 6 laps, slower guy has completed 4 laps. When will it happen the next time around? Quicker guy does 9 laps, slower guy does 6 laps. The time after that, 12 and 8 and so on. Right? Now we are asked how many times has the winner passed the other. And that depends on how many laps they run. So 3-kilometer race, lap length is 300 meters, or it's a race of 10 laps. The quicker guy, when he finishes 3 laps, he'll be overtaking him. When he finishes 6 laps, he'll be overtaking him. When he finishes 9 laps, he'll be overtaking him. And then he finishes the race. Or he'll overtake or he'll pass the other thrice. 3 times. When he completes 3 laps, 6 laps and 9 laps. When the slower guy at those points of time has completed 2, 4 and 6 laps. Out of 13 objects, 4 are indistinguishable and the rest are distinct. The number of ways we can choose 4 objects out of 13. Oh, lovely. So 4 are indistinguishable. So 1, 2, 3, 4. The rest are distinct, or 9 are distinct. Let's say we have A, B, C, D, E, F, G, H, I. Lovely. The number of ways we can choose 4 objects out of 13. I want to select 4 out of these 13. And that looks like it could be 13C4. 4 out of 13, 13C4. There's a catch there. In that 13C4, you might end up selecting this AB, or this AB, both are same because these are indistinguishable. I cannot tell them apart. So in 13C4, we'll do block 3, block 4 AB, that will get counted. Block 2, block 3 AB, that will also get counted. Both are same. I have two identical blocks with me. They are indistinguishable. Right? So what do we do? So the first thing to note, when objects are distinguishable, when they are different, which 3 you select, which 4 you select, they matter. When they are indistinguishable, the idea of how many you have selected matters, not which one you have selected. Out of these 4, you might select 2. Whether you select first and second or second and third or first and fourth, doesn't matter. So when they are indistinguishable, how many are selected only matters. When they are distinguishable, distinct, discrete, identifiable, not identical, then what you select matters. Right? Here, how many matters. Here, what matters. How do we solve this? Break it down. How many are you selecting? We could select 0 out of this, 1 out of this, 2 out of this, 3 out of these, all 4 out of this. Lovely. If you select 0 out of these, then you have to select 4 objects totally. Number of ways of doing that, 9C4. When you select 1 of these, you have to select 3 out of the 9, 9C3. 2 of these, 2 out of the 9, 9C2. 3 of these, 1 out of the 9, 9C1. 4 of these, nothing there. That is one way of selecting. All 4 get selected. Or we're looking at 9C4, which is 9 into 8 into 7 into 6 by 1 into 2 into 3 into 4. 2 into 3 is 6. 8 by 4 is 2. 2 into 7, 14 into 9 is 126. 9C3, 9 into 8 into 7 by 1 into 2 into 3. 9 by 3 is 3. 8 by 2 is 4. 3 into 4, 12. 12 into 7 is 84. 9C2 is 9 into 8 by 2. 9 into 4, 36. 9C1 is 9 and then 9C0, which is 1. 10, 16, 20, 26, 6, 2, 4, 12, 15, 5, 1, 256. There are 256 ways of doing this, which is quite different from 13C4. A beautiful question. One thing to remember, when objects are distinct, discrete, different, identifiable separately, then what you select matter. When objects are identical, same, indistinguishable, only how many you select matters. There's no way of saying some 2 out of these 4 are selected. Any 2 out of these 4 makes the same selection. Probability that a randomly chosen factor of 10 power 19 is a multiple of 10 power 15. 10 power 19 is 2 power 19 into 5 power 19. Any factor of this number will be of the form 2 power x into 5 power y. X can take values from 0 to 19. Y can take values from 0 to 19, or x can take 20 values, y can take 20 values, or this number has 20 into 20, 400 factors. Lovely. So that's a sum total of all factors. From that, we are selecting one. What is the probability that will happen to be a multiple of 10 power 15? 10 power 15 is 2 power 15 into 5 power 15. If you want any number to be a multiple of this, it will have to be the form 2 power a into 5 power b, where a is 15 or more and b is also 15 or more. Now comes the most interesting part. We want our number to not only be a multiple of this, but also be a factor of this. Totally there are 400 factors of this. Within that 400, we are thinking about the set of possible numbers which will not only happen to be a factor of this, but also a multiple of this. So we are looking for numbers in the form 2 power p into 2 power q. In order to be a factor of this, p and q will have to be 19 or lower. In order to be a multiple of this, p and q will have to be 15 or higher. Or p takes values 15, 16, 17, 18, 19. Q takes a similar set of values, 15, 16, 17, 18, 19. Or finally, the probability we are looking for is 5 into 5 by 20 into 20. Here the powers take value 15, 16, 17, 18, 19. Here powers take value 0, 1, 2, 3 all the way till 19. Given that you're selecting one out of these, what is the probability that will happen to be this for both the power of 2 and the power of 5? 5 into 5 by 20 into 20, 1 by 4, 1 by 4, 1 by 4 into 4, 1 by 16. Lovely. Number of acute angle triangles whose sides are 3 consecutive positive integers and whose perimeter is at most 100. It's a beautiful question. Perimeter is at most 100. The sides are 3 consecutive positive integers. Fine. So a bunch of simple constraints here. Consecutive positive integers, we're looking at 1, 2, 3, 2, 3, 4, 3, 4, 5, 4, 5, 6, etc. 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 Perimeter is at most 100. Perimeter here is 6. Here it is 9, here it is 12. Perimeter is 3 times the middle number. 33 into 3 is 99. So we can have 32, 33, 34. We cannot have 33, 34, 35. 33 plus 34 plus 35 is 102. That doesn't work. All of these are sets of 3 consecutive integers that add up to less than 100. We have not come to the triangle angle. We have definitely not come to the acute angle, triangle angle. Lovely. So let's look up the triangle thing. For triangle, sum of any 2 sides should be greater than the third one. This is out. Acute angle triangle, sum of the squares of the 2 shorter sides should be greater than square of the longer side. So here we are comparing 2 square plus 3 square with 4 square. 4 plus 9, 13 compared with 16. This is lesser. This triangle is obtuse angle. This won't get counted either. 3, 4, 5 is a right angle triangle. We know that. That won't get counted either. 4, 5, 6. Wonderful. 4 square plus 5 square compared with 6 square. 16, 25, 36. 16 plus 25 is greater than 36. This will count. Think about it. 4 square plus 5 square, 6 square. 5, 6, 7, 6, 7, 8, 7, 8, 9. All of these will have this property. When the numbers become larger, squares become increasingly larger. 1, 2, 3, 1 square plus 2 square is much less than 3 square. 2, 3, 4, 2 square plus 3 square is less than 4 square. 3, 4, 5, it becomes equal. If at 4, 5, 6, this is greater, after that will be greater. The sum, like 99, 100, 101 are 3 numbers that are very close to each other. 4, 5, 6 are also close to each other on the number line, but as a ratio, 4 to 5 is a 25% jump. 4 to 6 is a 50% jump. So the numbers are close to each other, we are going closer to acute angle triangle. Or if 4, 5, 6 satisfies this condition, everything else will satisfy this condition. We're effectively thinking about how many possible triangles are there. That is of 1, 2, 3, 3, 3, 4, 3, 4, 5, all the way till 32, 33, 34. Out of the 32 numbers, the starting point, leave out 3 or 29 is an answer. Beautiful question. We're thinking about consecutive integers, we're thinking about perimeter, we're thinking about it being a possible triangle, and then we're thinking about it being a possible acute angle triangle. All conditions one by one we tack on here. The straight line passing through the point minus 5, 4. So I'm going to draw the axis like this. Minus 1, minus 2, minus 3, minus 4, minus 5. 1, 2, 3, 4. So the line passing through this minus 5, 4. Such that the portion of it between the axes is divided by the point M into 2 equal halves. The line could be like this, like this, like this. But portion of it between the axes is divided by the point M into 2 equal halves. So if it were like this, then the part between the axes would be here. This point won't be dividing it into 2 equal halves. This second line tells us that the line is really like this. And so we call this point as P. This is A. This is B. We are told the portion between the axes is divided by the point M into 2 equal halves. So this is equal to this. This point is minus 5, 4. Point here should be h, 0. It's on the x-axis. Point here should be 0, k on the y-axis. Anytime you're getting questions with coordinate geometry where there's a line cutting the x-axis, circle cutting the y-axis, any point on the x-axis h comma 0. Any point on the y-axis, 0 comma k. The fact that we know half the coordinates, very powerful. Right? Now this is equal to this, or effectively this point, I've marked it as P, the point M, is a midpoint of this line. So we use midpoint formula. This point should be h plus 0 by 2, h by 2, 0 plus k by 2, k by 2. So it is h by 2 comma k by 2, or h by 2 is minus 5, or h is minus 10. K by 2 is 4, or k is 8, or there's a y-intercept of 8 and x-intercept of minus 10. Okay. We need to find the equation. Minus 10 comma 0 sits in this, 0 comma 10 sits on this, and so we need to, the equation would be x by minus 10, x by x-intercept plus y by y-intercept is equal to 1. We're getting an 80 somewhere, so multiply by 80 so that we get an 80 there. This is 80 minus 8x plus 10y equal to 80. 10y minus 8x equal to 80. That is this line. Right. Minus 10 comma 0 sits on this, 0 comma 8 sits on this. This both satisfy this. 10x minus 8y equal to. Idea here is that the point M is the midpoint of the segment AB, where A has coordinates h comma 0, B has coordinates 0 comma k. Plus cos square 3 pi by 8 plus cos square 5 pi by 8 plus cos square 7 pi by 8. First thing you have to notice straight away that this pi by 8 and the 7 pi by 8 need to be put together. These two need to be put together. Why? Pi by 8 and 7 pi by 8. Add that up. We'll get pi. 3 pi by 8 and 5 pi by 8. Add that up. We'll get pi. Now think about this. Think about cos theta and cos of 180 minus theta. If cos theta, cos of 180 minus theta is going to be in the second quadrant. So this is cos theta. This is going to be minus cos theta. All silver teacups. So second quadrant is going to be negative. Cos is going to be minus cos. Or cos square 5 pi by 8 is same as cos square 7 pi by 8. So I'm going to modify this question and say this is 2 times cos square pi by 8 plus 2 times cos square 3 pi by 8. And pi by 8 and 3 pi by 8. 2 times this plus 2 times this. Now if we can link cos square pi by 8 and cos square 3 pi by 8, we're good to go. And what do we do there? Pi by 8 plus 3 pi by 8. Pi by 8 plus 3 pi by 8 is 4 pi by 8 or pi by 2. Now we know, if you think about cos theta and cos of 90 minus theta, this is cos theta, this is sin theta. We are through. Cos 3 pi by 8 is sine of pi by 8. 90 minus theta, or this expression becomes 2 times cos square pi by 8 plus 2 times sine square pi by 8, or just 2 times cos square theta plus sine square theta, or 2 times 1, which is 2. Take this, figure out that these two are equal. Figure out that these two are equal, and figure out that this angle and this angle add up to 90 degrees. Okay, done. Another very interesting question. 1 by 1 square plus 1 by 2 square plus 1 by 3 square all the way up to infinity is pi square by 6. And what is the value of 1 by 1 square plus 1 by 3 square plus 1 by 5 square? And so very interesting, but actually a very simple question. Sounds very complicated. 1 by 1 square plus 1 by 2 square plus 1 by 3 square plus 1 by 4 square all the way is pi square by 6. The remaining part is 1 by 1 square plus 1 by 3 square plus 1 by 5 square all the way. What is this equal to? Think about it. What is missing from this? From this, what is missing here is 1 by 2 square plus 1 by 4 square plus 1 by 6 square, 1 by 8 square, etc., etc., etc. This is all even terms. This is a missing part. Now, from this missing part, all of these are even terms. So I can take out a 1 by 2 square. This missing part, the delta, take out a 1 by 2 square. This is 1 by 2 square into 1 by 1 square plus 1 by 2 square plus 1 by 3 square all the way up to infinity. Now, this we know is nothing but pi square by 6. Or the delta is 1/4 of pi square by 6. What is missing is 1/4 of pi square by 6. What is remaining is 3/4 of pi square by 6. Or the answer we are looking for is 3 by 4 times pi square by 6. Or it is pi square by 8. So the odd terms are difficult to compute. The even term is simpler. The even terms is nothing but 1/4 of the total. The odd term should be 3/4 of the total. 3/4 of pi square by 6, which is pi square by 8. This is an absolutely fabulous question. So we had several iterations of this. So it's a very good question, high quality question. So if you've not tried this question, hit pause on this video. You're going to get tons of value, especially in the idea of permutation, combination, probability particularly, by trying to solve this question and not just listening to this video. So please hit pause, try this, give this question a shot, give it some time, then come back and see this. And lovely. A man is known to speak the truth on an average 4 out of 5 times. Should be in politics. He throws a die and reports that it is a 5. The probability that it is actually a 5 is brilliant. This is a classic question where he has reported it as a 5 and you have to find the probability that it is a 5. And it's conditional probability, but the other way around. Given it is a 5, what is the probability that he'll report a 5? That is 4 by 5. If it is 5, it's a 4 out of 5 chance that he speaks the truth. That is clear. He has said it is 5. What is the probability that it actually is 5? That's what we're trying to do. And so we're going to use Bayes' theorem. Very interesting, very straightforward. Not a really straightforward idea, but an intuitive idea. And so what is Bayes' theorem about? It's step-by-step conditional probability. And so A happens, there is a probability of A happening, probability of A not happening. If A happens, there's 2 events. If A does not happen, the same 2 events. And then we go step by step. Given that the ball is turning, what is the chance that India will win? Given that the ball is not turning, what is the chance that India will win? What is the chance of India winning overall? Given that India has won, what is the probability that the ball did turn? Those are the different types of questions you can get in this. Right? So the standard framework for this is, don't worry about the post facto probability. Given that he reports a 5, what is the probability that it was actually 5? Forget that. Think about it in a chronological order. He rolls a die. It could be a 5. It need not be a 5. So let's start with that. So our man rolls a die. It could be a 5. It may not be a 5 or not a 5. So not 5. Given a 5, here he reports 5, reports something else, or reports not 5, does not report 5, reports 5, reports not 5. And then we'll carve out this entire probability and then go back to the reverse conditional aspect of it. Right? Given that it's a 5, what is the probability that he reports a 5? 4 by 5. What is the probability he reports something else? 1 by 5. What is the probability of it being a 5? He rolls a die. All this reporting, not reporting nonsense is not there. He rolls a die. What is the probability of it being a 5? 1 by 6. What is the probability of it not being a 5? 5 by 6. And then it is methodical. It is a 5. What is the probability he reports a 5? 4 by 5. Given it's a 5, what is the probability he reports something else? Does not report it's a 5. This is 4 by 5. This should be 1 by 5. It's not a 5. The probability that he reports 5 means he's lying, not speaking the truth. 1 by 5. It's not a 5. He reports not 5. 4 by 5. Fine. So this is the structure that you'll have to use for these questions. An event is rolling a die. 5, not 5. Then comes the reporting part. Reporting as 5, reporting not 5. Reporting as 5, reporting not 5. What are the possibilities? It lands on 5, he reports 5. He lands on 5, he does not report 5. It does not land on 5, he reports a 5. It does not land on 5, he reports not 5. That means each of these trends, what is the probability of this occurring? Is going to be 1 by 6 into 4 by 5. Of this occurring 1 by 6 into 1 by 5. Of this occurring 1 by 5 into 5 by 6. Of this occurring 5 by 6 into 4 by 5. Now if you just want to check, this 1 by 6 into 4 by 5, 4 by 30. 1 by 6 into 1 by 5, 1 by 30. 1 by 5 into 5 by 6, 5 by 30. 5 by 6 into 4 by 5, 20 by 30. I'm keeping the, not cancelling, I'm just keeping the denominator as 30. You think about it, this is 20 by 30. This is 5 by 30. 1 by 30. 4 by 30. Lovely. So 4 by 30 plus 1 by 30, 5 by 30 plus 5 by 30, 10 by 30 plus 20 by 30, 1. These trends, these are the sum total of all possibilities, they all add up to 1. We have not been asked what is the probability that it turns out to be 5 and he reports a 5. That is simple, multiply this and get this. We have not been asked that. We have been told clearly that he reports a 5 and then we have been asked what is the chance that it actually was a 5. That means the event that has happened is the fact that he has reported a 5. That means the event is either taken this path, it is 5 and he reports 5, or it is not a 5 and then he reports a 5. One of these two has happened. That means this and this are ruled out. They simply didn't happen. The question is not saying what is the probability that you will reach this point. The question is saying what is the, given that you have reached that point, what is the probability that you took this path? Brilliant. So given that you have reached that final point, that is, you have reported that it is a 5. That is, it is either 4 by 30 or 5 by 30. One of these two has happened. What is the probability that you came by this route? Think about it. Just the numbers are very friendly. Either you took this path to reach that, or you took this path to reach that. You finally reached the destination. What is the probability that you took the first part? So the destination has been reached, or your denominator is 4 by 30 plus 5 by 30. Numerator is 4 by 30. You're done. I'm going to just do the numbers all over again. 1, 6, 4 by 5, 1 by 5, 5, 6, 1 by 5, 4 by 5. 1 by 6 into 4 by 5, 1 by 6 into 1 by 5, 5 by 6 into 1 by 5, 5 by 6 into 4 by 5. Probability, this 2 by 15 divided by this 2 by 15 plus this 1 by 6. 2 by 15 by 2 by 15 plus 1 by 6, or 4 by 30 by 9 by 30, 4 by 9. Beautiful, delightful question. If only this question were as beautiful as just this. This question is brilliant. This question is beautiful because it is not this simple. This looks simple. Let me rephrase it. This doesn't look simple. Standalone, this question is still nice, but we have missed one big chunk. Right? So the answer, surprising as it may, we've got 4 by 9. It's available in the answer choice. Probably is not right. Right? So what are we missing? What is something that we perhaps are not getting right? Think about it. We have thought about this and structured it as getting a 5, reporting 5, not reporting 5. Not getting a 5, reporting 5, not reporting 5. And not getting a 5, reporting the correct one, the chance is 4 by 5. Reporting the wrong one, choice is 1, probability is 1 by 5. The correct one is not reporting 5. That's correct. The wrong one is just not right. It doesn't mean it has to be 5. This part is tricky. Think about this. Suppose I get a 4. The probability of reporting 4 is 4 by 5. Good. Probability of not reporting 4 is 1 by 5. Reporting 4, not reporting 4. Exactly complementary events adding up to 1. Good. Probability of reporting 4 is 4 by 5. Not reporting 4 is 1 by 5. Not reporting 4 is not the same as reporting 5. Very crucial point there. Right? So if you're not getting 5, probability is 5 by 6. Reporting correctly that will be 4 by 5. Reporting incorrectly, that will be 1 by 5. Right? But reporting correctly is not exactly same as not reporting 5. Reporting incorrectly is not exactly same as reporting 5. If I put a 4 and I report 3, I am still incorrectly reporting, but I am not reporting a 5. Fine, so that part is very, very, very crucial. So I am going to dive deeper into that. We are not getting a 5, but say we get a 4. There is a 5 by 6 probability of that happening. That is not 5. We are thinking about only 4, it is 1 by 6. But I am considering the not 5 category, taking one specific instance of it being 4. Right? I report a 4, that's a 4 by 5. That is easy part. I am not reporting 4, that is 1 by 5. Good, wonderful. In this, if I am not reporting 4, I am reporting 1, 2, 3, 5 or 6. Within this, I could be reporting a 5 or I could be not reporting a 5. 1, 2, 3, 6. And reporting 5 probability is 1 by 5. Not reporting 5 probability is 4 by 5. Or in this 1 by 5, we multiply with this 1 by 5 to get 1 by 25. This 1 by 5 into 4 by 5, we get 4 by 25. Now we come back to our original breakdown and say, not getting 5 is 5 by 6. Reporting it as a 5 is 1 by 25. Not reporting as a 5 is 24 by 25. Why? Suppose this were a 4. I'll report it as a 4 in 4 out of 5 turns. I'll report it as 1, 2, 3 or 6 as 4 by 25. Reporting as 5 is only 1 by 25. 4 by 25 plus 4 by 5 is 24 by 25. This part is not just 4 by 5. It's the most important part. You get a 4, reporting as 4, there's a 4 by 5 chance. Reporting not 5, there's a 24 by 25 chance. You could report incorrectly. You could report it not as 4, but as 1, 2, 3 or 6. That is still possible. That has to get accounted for here. After this, we are back to Bayes theorem. How so? We're back to the same probability. This is 5 by 6 into 1 by 25. This is 1 by 6 into 4 by 5. This is 2 by 15. This is 1 by 30. And the final probability we have will be 2 by 15 by 2 by 15 plus 1 by 30, or 4 by 30 by 4 by 30 plus 1 by 30, 4 by 30 by 5 by 30, which is 4 by 5, which seems intuitively right. What is if he reports a 5, the probability there is actually a 5, he speaks truth 4 out of 5 times, it should be roughly in that ballpark. It's correct. Unfortunately, in the exam, that choice was not available. So I don't know what they would have done. I don't know whether they fixed it. I don't know what they did with it, but that's all incidental. The key point here is this question. If you're not reporting 5, that does not mean, that is not the same as getting it wrong. When you're not reporting 5, could mean you're reporting 1, 2, 3, 4 or 6. It could be 4, in which case you're getting it right. 1, 2, 3, 6, wrong, but not 5. So there's that caveat, that one little bit thing that you still need to worry about. That's what makes this question not just good or great, but magically good. So beautiful question. There's tons of value in just going through this question and saying, oh yeah, lovely question. So please do that. Take that value. Best wishes for your exam. Do this. Log to the base 5, log to the base 8 of x square minus 1 is 0. Lovely. Log something to the base 5 is 0, or this something should be 5 power 0, which is 1, or log to the base 8 x square minus 1 should be 1. Log something to the base 8 is 1, or that something is 8 power 1, which is 8, or x square is 9. X square is 9, or x is plus or minus 3. So 9 minus 1 is 8, log 8 to the base 8 is 1, log 1 to the base 5 is 0. So 3 could work, minus 3 could work. A possible value of x is 3. Others don't work. Consider the following statements. 0 less than x less than 1, 1 by 1 plus x is less than 1 minus x plus x square. 1 by 1 plus x is This range it is greater than, this range it is less than, this range it is greater than. So the expression here took me a while to wind around. It's basically taking 1 by 1 plus x and comparing it with 1 minus x plus x square. I want to simplify this. Then say, when is 1 minus x plus x square greater than 1 by 1 plus x? Let's solve for this inequality and then we'll plug it in there. Let's solve for this, then we'll plug it in there. Right? So how do you solve for this? You want to effectively say 1 minus x plus x square, 1 minus x plus x square minus 1 by 1 plus x is greater than 0. The LCM is 1 plus x. So we have 1 plus x into 1 minus x plus x square minus 1 divided by 1 plus x is greater than 0. This a plus b into a square minus ab plus b square, which is nothing but a cube plus b cube. This is 1 plus x cube minus 1 by 1 plus x, which is greater than 0. Or this effectively is x cube by 1 plus x greater than 0. X cube by 1 plus x, when will it be greater than 0? The ranges we are talking about are 0 to 1 and minus 1 to 0. Think about those ranges. X cube by 1 plus x, when will it be greater than 0? When x is positive, this will be positive, this will be positive. So when x is greater than 0, this will hold good. Or in the range 0 less than x less than 1, 1 minus x plus x square greater than 1 by 1 plus x. So 1 is correct. But obviously means 2 is wrong. The other range is minus 1 to 0. Minus 1 to 0, x cube is going to be negative, 1 plus x is going to be positive, or negative by positive. This will not hold good. Or in the range minus 1 less than x less than 0, 1 by 1 plus x is greater than this. This holds good. This is a choice. This doesn't hold good. Or we are looking for an answer choice that says 1 and 4 both hold good. The key thing here is to we are comparing these two, call it an inequality, bring everything to one side and then compare and solve for that inequality. Otherwise, plugging in value by value for this range could be a nightmare. Second thing, don't just cross multiply and say the x cube is greater than 1. That doesn't work because there's a 1 by x, 1 plus x in the denominator. So sometimes cross multiplying can cause nightmares. So bring it all to one side, take the LCM and then simplify. Don't cross multiply when expressions are involved. Right? So 1 and 4 both need to hold good, which is 1 and 4 here. This one, that works. 50 liters of a mixture of milk and water contains 30% of water. This mixture is added to 80 liters of another mixture of milk and water that contains 20% of water. 50 liters, that is 30% water. So 50 liters, water of 15 liters, milk of 35 liters. It is mixed with 80 liters of another mixture, 80 liters, that contains 20% water. That is, water would be 16 liters. 20% of this, 1/5 of this. Milk would be the remaining 64 liters. How many liters of water should be added to the resulting mixture to obtain a final mixture that contains 25% of water? Okay, we're mixing these two. When we mix these two, out of 130 liters, 15 plus 16, 15 liters is water here and 16 liters is water here. 31 liters is water. The remaining is milk. Right? How much should be added to obtain a final mixture that contains 25% of water? So we add something and then finally it should be 25%. 31 into 4 is 124. 32 into 4 is 128. 33 into 4 is 132. This number, you add some x here, add the same x here because we're not adding any milk. That into 4 should be this. 25% is 1/4. X is not 1, that is, it becomes 32. 32 into 4 is 128. If x were 2, 33 into 4 is 132. Yeah, that works. The algebraic way of solving this, we're going to say 31 plus x into 4 is 130 plus x. Solve this, we'll get x equal to 2. That's a more methodical, simpler algebraic way of doing it. But you can just scan the numbers. To 31 you add 2, you get 33. 33 into 4 is 132, which is nothing but 130 plus 2. A very routine question. Three workers working together need 1 hour to construct a wall. The first worker working alone can construct a wall twice as fast as the third worker and complete the task an hour sooner than the second worker. And the average time in hours taken by the three workers when working alone to construct the wall is okay. First of all, the simple work time question, it sounds very doable. I would jump on it, but I hate the choices. This root 33 and all that. There's something funny about this question. Straight away, I'm not liking this question because of this. So it should be savvy. It's a competitive exam. Right? But we're practicing here, so let's dive in. From an exam point of view, I might skip this and come back later on. But right now, we're going to solve this. The first worker working alone can construct the wall twice as fast as the third worker. So worker 1 is twice as quick as the third worker. So I'm going to say worker 1 completes it in n hours and worker 3 will take 2 n hours. The number of hours. And the worker 1 can complete the task an hour sooner than the second worker. But worker 2 takes n plus 1 hour. Right? Now we have one more piece of information. When all three of them work together, the entire task can be done in 1 hour. And then we want to find the average time in hours taken by the three workers when working alone to construct the wall. So we want the average of n plus 1 and 2n. What do we know? We know that all three of them put together can complete this in 1 hour. And so what gets done in 1 hour? In 1 hour, worker 1 will do 1 by n of the task. Worker 2 will do 1 by n plus 1 of the task. Worker 3 will do 1 by 2n of the task. Between them, they complete the entire task. Or we have this wonderful equation, 1 by n plus 1 by n plus 1 plus 1 by 2n equal to 1. And what do we need to find out? We need to find out average of n plus 1 and 2n. Or we need to find out this plus this by 3. 2n, 3n, 4n. So what we want to find out is 4n plus 1 divided by 3. This is what we need to find out. What we know is this. Okay? Let's simplify this. We can call this 2 by 2n. So we have 3 by 2n plus 1 by n plus 1 equal to 1. Let's take the LCM and simplify. I'm going to go to the next step. 3 times n plus 1 plus 2n. 3 times n plus 1 plus 2n divided by 2n into n plus 1 is equal to 1. Or 3n plus 3 plus 2n equals 2n square plus 2n. The 2n disappears. We have 2n square minus 3n minus 3 is equal to 0. Straight away, this one doesn't get factorized. And we kind of knew it won't get factorized by just looking at this number. So we're going to have to resort to completion of squares. So I'm going to think of this as n square minus 3 by 2n equals 3 by 2. I'm taking this minus 3 this side, calling it as 3, and then dividing by 2. Why? Because dealing with n square is easier. And so 3 by 2n, we know a minus b whole square is a square minus 2ab plus b square. So 2a should be minus 3 by 2, or we are thinking about minus 3 by 4 whole square. So n square minus 3 by 2n plus 3 by 4 whole square equals 3 by 2 plus 3 by 4 whole square. Or this is 3 by 2 plus 9 by 16. Or 3 by 2 is LCM is 16. 3 into 8 is 24 plus 9 by 16 or 33 by 16. Fine. N minus 3 by 4 whole square is 33 by 16. Lovely. I like 33 by 16. You know why? Because this means n minus 3 by 4 is going to be plus or minus root 33 by 4 root 16. Why do I like root 33? Because of this. Fine. Or n equals 3 by 4 plus or minus square root of 33 by 4. Straight away it cannot be minus and n will become negative. That we can rule out. It is 3 by 4 plus root 33 by 4. Or n is 3 plus root 33 by 4. What do we want to find? We want to find the average of those three things. We want to find 4n plus 1 by 3, which is good. So 4n plus 1 by 3. So this into 4 plus 1 by 3 into 4 is lovely because the 4 will get cancelled. So I'm going to simplify that. 3 plus root 33 by 4. 3 plus root 33 by 4. This is n into 4 plus 1 divided by 3. This goes off, or we have root 33 plus 4 by 3, which is this choice. And the algebra of it is a pain. You have to think about completion of square. You have to be careful about n. We need to manipulate it slowly, but conceptually not that difficult. Work time is not a conceptually tough topic. In a class, students are assigned roll numbers from 1 to 140. All students with even roll numbers opted for cricket. All those with roll numbers that are divisible by 5 opted for football. Those with roll numbers that are divisible by 3 opted for basketball. The number of students who did not opt for any of the three sports is classic set theory question. We know A union, B union, C. So here we can find out cricket union, football union, basketball. Once we find this, 140 minus this is the answer we are looking for. And we want to find the number of students who did not opt for any of the three sports. Cricket union, football union, basketball is number of people playing cricket plus number of people playing football plus number of people playing basketball minus cricket intersection football minus football intersection basketball minus cricket intersection basketball plus cricket intersection football intersection basketball. A union B union C is A plus B plus C minus A intersection B minus B intersection C minus C intersection A plus A intersection B intersection C. That's what we're plugging in here. Now, these are all multiples of 2 even numbers. 70 of them are there. Football is multiples of 5, 10, 15, 20 all the way till 140. 28 of them are there. Basketball, a set of all numbers which are multiples divisible by 3. So 140 by 3. 46 into 3 is 138. So 46 will feature in this list. Not 46 point something. That reminder will go away. Cricket intersection football. So even numbers there are multiples of 5 or multiples of 10. Cricket intersection football, numbers that are multiples of 2 and multiples of 5, multiples of 10. Sorry, I should have said multiples of 10, not written down 10. How many multiples of 10 are there? There are 14 multiples of 10. 10, 20, 30, 40, all the way till 140. Football intersection basketball, multiples of 5, multiples of 3. The intersection will be multiples of 15, 15, 30, 45, 60, all the way till 135. 135 is 15 into 9 or 9 numbers in this list. Cricket intersection basketball, multiples of 2, multiples of 3 or multiples of 6. How many multiples of 6 are there? 138 is 3 into 46 or this is 6 into 23. We cannot go beyond that, or 23 are there. Cricket intersection, football intersection, basketball, which basically is multiples of 2, 3 and 5, which is multiples of 30, 30, 60, 90, 120, 4. Or we're effectively doing 70 plus 28 plus 46 minus 14 minus 9 minus 23 plus 4. Minus 14 minus 9 is minus 23, minus 23 minus 23 is minus 46. It's a plus 46 here. All of this goes to 0. 70 plus 28 plus 4. 70 plus 28 is 98 plus 4 is 102. Brilliant. Just remember, even though there's a beautiful 102 choice available, 102 is cricket, union, football, union, basketball. 102 people play at least one of these three sports. The question says, how many did not opt for any of these? Out of the 140, we knock off this 102. We have 38 remaining. The remaining, after accounting for cricket, union, football, union, basketball, the remaining is 38. as a real sitter here. And so f of x equals x square plus log x to the base 3. G of y is 2y plus f of y. The value of g of 3. For finding g of 3, we need to use f of 3. Let's find f of 3. F of 3 is 3 square plus log 3 to the base 3. Log 3 to the base 3 is 1. This is 9. 9 plus 1, which is 10. G of 3 is 2 into 3 plus f of 3, which is 10. 6 plus 10, 16. That's marks in the back. Very, very simple question. Absolute sitter. You must find these and knock them off.